Well, dear Professor Aghion, dear Philippe, dear colleagues and friends, it is a huge honor and a great delight that on this first lecture, this first lecture of the Academia Europea's new initiative, College of Excellence, we shall have as the speaker Professor Philippe Aghion of the Collège de France. This is a huge delight for us, and I'm very happy that so many are in this, the largest lecture hall of our Congress. Please let me say that Professor Aghion was educated originally in mathematics and mathematical economics at the École Normale Supérieure, Cachan, and in Paris. He received his PhD from Harvard University, and for many years he was actually a professor at Harvard. He also had held positions at the UCL, and he was an official fellow of Nuffield College, Oxford. I don't know how many of you know what it means to be an official fellow of Nuffield College, but it basically means you can do whatever you want and you devote yourself wholeheartedly. It's a very enviable position. Now, Professor Aghion is professor at Collège de France, but he also holds a position at the London School of Economics and Political Science and at INSEAD. I will not give a long presentation of his research. That has been done in many contexts, not least on our own websites. There is full information, or very rich information rather, about his research. Let me just utter one or two words. Professor Aghion's research is focused on the economics of growth and on contract theory. In particular, together with Peter Howitt, he pioneered the so-called Schumpeterian growth paradigm, examining and analyzing what could be meant by processes of creative destruction. Later, he has extended this paradigm to analyze the design of growth policies and the role of the state in such processes. And that is an important addition, because Professor Aghion is a very engaged, I would say even passionate scholar and lecturer, but he's also a compassionate individual. He cares about human beings. He's not just describing tumultuous processes of destruction. He cares about how individual human beings fare in those processes. And that's a very important addition, I would say. Now, I will only say that there are very many international honors that have been bestowed on Philippe Aghion over the years. I should also mention he is a fellow of a member of several academies, including the American Academy of Arts and Sciences, the British Academy, and last but not least, Academia Europea, of which he is a long-standing member. Some of the most important recognitions in terms of prizes that he has received is the John von Neumann Award in 2009, the BBVA Frontiers of Knowledge Award, which is handed out here in Spain. And I should also mention that he received the highest distinction of our Academy in 2021, namely the Erasmus Medal. And some, or many of you, I hope, will remember his lectures here in this building on those occasions. You will rarely have heard a lecturer who speaks with equally concise manner and in a crystal clear mode of argumentation, but also with great engagement and with great passion, in a way that means that you open up for a conversation not only across the social and human sciences, but across the scholarly and scientific domains at large. And that is not just an excursion into a lofty domain of theory. It is an excursion where care for the human beings who are involved in creating what we call societies is at the heart of the matter. I will also mention to you, and I do this with delight on behalf of Jome, that on the 9th of September, it was decided that Professor Aghion will receive the Hypatia Prize of this year, and this will be officially announced also by the city tomorrow, I've learned. This is it's a large prize, and I think it is a great honor for us to have such a prize winner. Many of you know that on the Monday of this week, it was announced that Professor Aghion is a recipient of the 2025 Sveriges Riksbank's Prize in Economic Sciences in memory of Alfred Nobel. This is a huge delight to us, and it makes us very proud to have Professor Aghion among us today. I would just say that to Philippe, warmest congratulations from Academia Europaea on this occasion, and we are absolutely delighted that you are giving this first lecture in our College of Excellence. You are warmly welcome and warmest congratulations, and I think we can greet Professor Aghion with a round of applause.
Thank you so much.
And now I give the word to Philippe.
Can you hear me?
Yes.
My apologies for not being able to be with you today, but since Monday, I've been totally swamped. It's a fantastic, of course, and very unexpected news that I received on Monday. And of course, it implies that my life, I am no longer owner of my time since then. And I simply could not make it today with you, and I apologize for not being with you in person. So thanks so much to invite me and to give this lecture. So I will try to share slides. I hope that works. Voila, here we go. Okay, thank you so much. I will. So let me start. Let me call this lecture "Should We Fear AI?" So last year, in 2024, I was fortunate to co-chair a commission to prepare a report for President Macron on AI. It's called AI, Our Ambition for France, which I co-chaired with Anne Bouvreau, who organized the AI summit that took place in Paris in February of this year. So AI, as I'm sure you know, first developed, it goes back to 1956 and to Turing. It first developed in the form of deductive rules of the type if something, then something. That's what we call the symbolic approach, which is based on reasoning and instructions. Although the symbolic approach has not been abandoned, a statistical approach to AI has been gaining ground since the 1990s, and with the advent of machine learning particularly. Unlike the symbolic approach, the statistical approach involves no explicit human instruction. The machine is trained to recognize links from a set of training data, and the machine then applies those links to new data to perform a task. The success of the statistical approach rests on two main ingredients, two main legs: data and computing power. That's very important for what we'll be saying, what I will say next. So now the AI revolution is a true general purpose technology revolution. AI affects all domains of activity: the economy, public services, the organization of work, media, culture. And within that revolution, there is another revolution, which is the emergence of generative AI, which represents an unprecedented acceleration within the AI revolution. Just to give you an idea, it took 2.5 years for Netflix to reach 1 million users. It took 2.5 months for Instagram to reach 1 million users. It only took 5 days for ChatGPT to reach 1 million users. Now, on AI, there is a pessimistic and I would say cautiously optimistic view. The pessimistic view is that AI would yield very little growth impact and would have a very negative employment impact. My own view, which is a little bit less pessimistic, or I would say cautiously optimistic, is that technologically speaking, AI has a growth potential which is considerable, and it also has the potential to create new jobs. But for this to happen, you need appropriate policies and institutions. So you see, prosperity is always the joint result of technology and institutions. I'm not very worried about the technology. I'm very worried about our inability to adapt the technological revolution by setting up the proper policies and institutions. Okay, so let me first start talking about growth and AI. AI should boost productivity growth because it automates both the production of goods and services and the production of ideas. That's something we emphasize in joint work with Ben Jones and Chad Jones. Why is it that AI facilitates the production of ideas? AI helps find solutions to complex problems. AI facilitates imitation and learning. AI can become self-improving. And AI, a lot of new ideas you get by recombining all ideas. And AI makes it much easier to recombine existing ideas to generate new ideas. So you can generate many more ideas with AI by recombining existing ideas. And the other thing that AI allows you to do is to be much faster at selecting among those potential new ideas the one that you want to implement. Okay, so if ever we thought that ideas would be harder to find, particularly with AI, I believe that ideas may not be harder to find. They might be easier to find. So I don't want to put you in math there. I go right there. There is a very interesting paper that's now published in the Quarterly Journal of Economics by Eric Brynjolfsson and co-authors called Generative AI at Work. And there in that paper, the authors, they look at the effect of introducing ChatGPT on the productivity of employees in a US firm. Now, the US firm is a Fortune 500 company, and this US company, which is a very highly performing company, it's a company that advises managers of small and medium-sized enterprises on the adoption of enterprise software. So you're a manager of an American or US or whatever small and medium-sized enterprise. You call upon this large Fortune 500 company for help to adopt new software, and then this company directs you to employees all over the world, in particular in the Philippines. They employ people in the Philippines, and in fact, the job in those people in the Philippines consists mainly in answering the question that these SME managers may have on how to install software. So one way to measure these Philippine agents' productivity is by looking at the number of resolutions per hour. And so what they do in that paper is that they do a diff in diff. In fact, the diffusion of ChatGPT has been progressive in that firm, in that Fortune 500 US company. So which means that for a while, some employees have access to ChatGPT, but other employees don't yet have access to ChatGPT. And so what you do is the treatment group is those employees who have access to ChatGPT, that's the treatment group, and the control group are employees that are of similar education, productivity, experience that haven't yet got access to ChatGPT. And you see that getting access to ChatGPT increases the productivity of the Philippine agents. You see, they can answer more queries within a given day or within a given hour. Okay, it increases productivity by 14% 1 month after AI adoption. It decreases productivity up to 25% already after 2-3 months. So that's a substantial boost in productivity. You see that AI adopting ChatGPT significantly increases the productivity of these employees. Okay. Now, how do you go from micro to macro? This is one firm. What you would like to go is to go to infer what would be the aggregate growth effects of AI. So there you have two ways to approach the problem. One way is to say, let's extrapolate from previous general purpose technologies, electricity, IT, and say, well, that could give us a guess of the growth boost that would be induced by introducing AI, okay? Another approach is to we know that AI automates tasks in the production of goods and services. What you could do is directly adopt a task-based approach. So if you do the extrapolation, what we know is that the electricity revolution in the US, which took place really where you had the takeoff of the electricity revolution was in the 1920s. For 10 years, the revolution of the 1920s in the US boosted productivity growth by 1.3 percentage point. If productivity was growing at 1% per year prior to the diffusion of the electricity general purpose technology, for 10 years, you would have a 2.3 percentage point, 2.3% growth per year for 10 years, and then you go back to 1%. Now, the IT revolution boosted growth by 0.8 percentage point per year for 10-year period. If you are growing at 1% per year prior to the diffusion of the IT technology, for 10 years into the diffusion, essentially between 95 2005, the growth rate jumped up to 1.8% per year if it was at 1% before for 10-year period. So that would give this kind of figure. You see, without AI, it's the dotted line that would show the evolution of GDP. And with AI, you have a steeper curve for 10 years, and then the green curve becomes again parallel to the dotted curve after 10 years, okay? But of course, GDP is permanently higher with AI than without AI, okay? But this is just extrapolating. Now, there is another way, is to adopt a task-based approach. So that's what Daron did in a paper that he published in Economic Policy. He relied on the task-based model that he developed with Restrepo to estimate the effect of AI adoption on total factor productivity, and concluded to the fact that AI adoption would not increase productivity growth by only 0.07 percentage point per year. I mean 10 times less than IT. And the way that Daron did is that you said, I put myself in a situation where the Holton theorem can apply, which is fine, which is perfectly, I think, a good idea. And then what he did is to say, well, TFP gain over 10 years, it depends on the GDP share of tasks that are exposed to AI. Among those tasks, what is the share of tasks for which it is really profitable to introduce AI? What is the labor share adjusted for AI exposure? And the labor cost saving enabled by AI. And the TFP gain is the product of these four terms, you see. And Daron Acemoglu, what he did, Daron, is to use existing literature to put numbers on each of these four factors. And he arrived at the 0.07. Now, with Simon Bunel, we went back. We said, okay, I think we are perfectly happy with the methodology that Daron has adopted, but what we will do is to look more precisely where did he get these numbers. So for the share of tasks that are exposed to AI, he took it from a paper by Elundu, okay? And but there are other papers, and IMF, for example, thought that 60% of tasks in the US should be subject to AI, and on average 68% or 60% also on average in developed economies, and 68% in the UK. So the interval to consider, in fact, if you look at the whole literature, it's anything between 18.5% of tasks and 68% of that. And Daron was almost at the lower bound by taking the 19.9. Okay, then I look among those tasks that are exposed to AI, what is the share of exposed tasks for which it is profitable to implement AI? And Acemoglu then, what Daron did is to draw from a paper by Svanberg that estimates that if you restrict attention to visual tasks, that at today's cost, 23% of visual tasks exposed to AI are profitable to automate for American firms. But this is assuming no technical progress, no cost reduction over time. But in fact, of course, technical progress will make the adoption cost go down over time. And Svanberg and co-authors themselves propose three scenarios of annual cost reduction respectively of 10%, 20%, and 50% per year, leading to 30%, 50%, and 80% of visual tasks exposed to AI that will be profitable to automate in 20 years down the road. So the right number there would not be 23%, but rather anything in the interval between 23% and 80%. Okay, and even there, we focus on visual tasks, which are here, but there are tasks, for example, which is like understanding writing or language, for which much more quickly here we have where we are currently, and that, the performance, and 0 is the human performance, and that's how fast. The steeper the line, the faster it is for the machine to catch up with the humans. And in fact, visual tasks are not those for which the cost of adoption is going down fastest. In fact, restricting attention to visual tasks also, it's a way to underestimate the share of tasks that will be profitably automated by AI. Okay, so this downward bias, by the related, linked to the fact that we take only visual tasks and not other tasks, means that in fact the interval should not be 23-80, but even beyond 80%. Now we come to the labor cost saving enabled by AI. What Daron does, he does an average between 14% in a paper in Noy and Zhang, and the 19, and you remember the 14% that I had here after 1 month of Brynjolfsson et al. But you know that after 3 months, you jump up to 25%. So if I just take the average between the 40% of Noy and Zhang and the 25, instead of having 27, it will be 33. So the lower bound should rather be 33% of labor cost saving enabled by AI rather than 27%. So at the end of the day, you see anything in the range between 0.07 or 0.08 percentage point and 1.24 percentage point is that's the range of increase in productivity growth annually that AI can yield. And our median scenario with my co-author is to predict an increase in productivity growth due to AI of about 0.68 percentage point per year over a 10-year period. I mean that if I grew before AI at 1% per year, I grew at 1.68 for 10 years, and then I go back to 1%, okay? So that's very much in the same ballpark as the growth increase induced by IT. So it's very interesting because looking properly using the task-based approach gets me to a very similar number than if I just extrapolate from previous general purpose technologies, okay? But there, I didn't take into account the fact that AI automates not only tasks in the production of goods and services, it also automates tasks in the production of ideas, okay? And in particular, so in fact, what you should have is, instead of having the red curve, you should have this blue curve. So that means a faster growth within the next 10 years, but also permanently faster than without AI, because permanently, thanks to AI, ideas will be easier to find, because the innovation technology will permanently be upgraded thanks to AI. Okay. In fact, very, very interesting, if you look at the share of patents that cite AI papers, we call them AI patents, it has surged over since the 2010 years. You see what I mean? You have an upsurge of patents that cite AI papers. I call them AI patents. And why are those interesting? Because I can look at their characteristics. We can see whether, if you restrict attention to AI patents, do you get more citations? Yes, M1. Do you get more novelty? Yes, M2. Do you get higher quality using OECD index? Yes, M3, M4, M5. Do you get more generality? Yes, using M6, and originality using M7. It's very interesting that we have, thanks to AI, you have an explosion of AI patents, or patents that cite AI papers, and those are much better quality patents, therefore with higher growth potential. We haven't yet evaluated the additional growth, so we go much beyond the 0.68 additional percentage point for a 10-year period. Thanks, if we properly, we can look at the growth impact of the fact that you have these AI patents. Okay, that's still to be done. That's still research in progress. So that means that the 0.68 for 10 years is a lower bound on the growth potential of AI. But now there is a downside, is the lack of competition can be an obstacle. Here, I look in the US, you see, I look at the average annual TFP growth. You see that growth, TFP growth, soared up between 95 and 2005. That was the IT revolution. But then you observe a big decline in TFP growth in the US. That's the secular stagnation enigma. And in fact, what has happened is that this very much is linked to the emergence of superstar firms. You see, Google, Microsoft, Walmart, those firms, knew how to harness the power of IT better than other firms, and they expanded, and that's why you get a rising rate of concentration in services, but also in other sectors of the US economy, an acceleration in concentration exactly at the time where you had the diffusion of IT. So you had the emergence of this firm. Initially, this firm boosted growth, but the problem, and here you look at the average markup in the US went up, that's the red line, but not so much because within firm the markup went up, that's the blue line, there is no upward trend in the blue line. It's the black line, it's the composition effect. The high markup firms that were the superstar firms became increasingly more pervasive in the US economy, thanks to merger and acquisitions, thanks to be able to do merger and acquisitions without any limit, because competition policy was not appropriate. So what happened then is that you had these superstar firms, they, thanks to IT, they expanded and they became hegemonic, and they ended up discouraging the entry of new innovators. That's why if you look at the entry rate of all kinds of firms of all sizes in the US, you see that the entry rate of new firms has gone down since the 2000s, okay? And that has, of course, led to this secular stagnation, to the growth decline that you have here. Now, why is that a concern for AI? Because AI, the upstream segments in the AI value chain is dominated by, are dominated by few superstar firms. Cloud is dominated by 3 superstars, Amazon, Google, Microsoft, and you have only one big actor, GPU, on the market for graphic processors. So my point is that AI has a growth potential. I'm more optimistic than Daron, technologically speaking, but where I'm pessimistic or less optimistic is that we need to adapt competition policy. In the US, they should have be more careful when allowing the superstar firms to expand. They should have insisted on data sharing and on making sure that the merger and acquisition will not stifle future entry and future innovation. Competition policy in the US, like in Europe, is very much static based and is not sufficiently dynamic. And so my point there, and I want to look, I want to look also at the employment effect. So you need to adapt. You see, the thing is that my view there is that AI has a big growth potential, but to harness this potential, you need to foster competition. Open source, ease data access, extend the Digital Market Act to the whole value chain of AI, including the cloud, avoid excessive regulation. When you have excessive regulation, you need regulation, of course, but when you have excessive regulation, the large incumbent firms know how to cope with them, but the new entrants don't. It's become an entry barrier. But at the same time, I believe in industrial policy. Invest in local computing power, invest in AI diffusion, and in AI-based research. So that's more like industrial policy and research policy of government. So I believe that we should combine a renewed competition policy and an industrial policy which is smartly designed and allows, and makes it easier for new entrants to come in, because you would have available local computing power in particular. So my view there, you see, is that technologically speaking, AI has a big potential, but we need to adapt institutions, and in particular, we need to adapt our competition policy to make it more dynamic and more friendly to smartly design industrial policy. I don't know how much time I had. Is the time elapsed? I don't know. Hello? I'm sorry. I don't know at what time I'm supposed to finish.
Philippe, we started a bit late, and I
Yes.
think when we were in communication, I said roughly 10, 20 minutes. And I think so speak, well, not for too long more, and because we have a principle.
Let me conclude. My conclusion is that AI has a big potential, and we need to adapt our institutions, and we need to reform European policy. And that's where the Draghi report comes in. So maybe that's what I wanted to say. I'm not pessimistic on the technology. I am like a fighting optimist on the need to reform our doctrine, our economic doctrine, and our policies and institutions.
Yeah.
Thank you very much.
That's wonderful.
Thank you. Thank you.
Well, we have an important meeting of all the members, but I still would like to keep to the rule that we have in the Royal Swedish Academy of Sciences. No matter how famous you are, you shouldn't get away without one question. So one or at most two brief questions, and then Philippe will answer them both.
Yes, yes.
Are there anybody? Yes? Yes, and Maria. Please. Yes, it's you.
Thank you. Thank you, of course, for a brilliant talk. I want to ask about the problem of inequality. I mean, I happen to share your optimism, but you pointed out that a few companies control the technology. Can we avoid the problem of increasing inequality with this specific technology?
Yes,
Thank-
yes. So, yeah.
Can we take Maria's question also, and then you can answer to both?
Thank you very much. Do we need in Europe an AI institute like we have one CERN for particle physics and ESA for space? Do we need one for AI?
Yes, the answer is absolutely yes. That was one recommendation we made in the AI summit in Paris. We proposed a CERN, the equivalent of CERN for AI. Absolutely, yes. Well done. Great that you propose it. Yeah. Great that you mentioned it.
Thank you so much. Thank you so much.
The other question on inequality. I believe that, to deal with inequality, of course, you need a progressive taxation is important. Yeah. I'm a good social democrat, But you also need competition, because inequality is the fact that you have incumbents that prevent new entry. So that, to make new entry, you need good competition policy to make sure that the incumbent firms do not stall the new entry. And we need good education system to have many people being able to become inventors, or many people not left out of the innovation process. So a good education system, good flex security like in Denmark, and good competition policy. I think those are competition, education, flex security, those are pillars of reconciling growth to make growth more inclusive. To boost growth, to harness the power of AI, and at the same time make growth inclusive, make sure that nobody is left out of the process.
Yeah. And all those points, Philippe, they are invitations to future conversations and real research. So thank you so much once again.
Thank you so much. Thank you. It's a pleasure.